Hey everyone, welcome back. In this lesson we're going to continue with some more practice problems that involve using a single variable. And then in the next video or two I'm still debating on whether I want us to do a whole bunch of word problems or if perhaps that's something to save for the assignment. But at any rate, we'll see if we can do a word problem or two for practice in one of the next couple of videos before moving on to working with two variables. But we're just going to up the ante a little bit in this one. It'll still be more practice problems, so if you want, that could be your title. It could be more practice problems or more practice problems with one variable. And the first one will be reasonably simple, so we'll try and speed through it. And then after that, practice problems, there we go. And then after that, we'll make things ever so slightly more complicated. Not too complex yet, because that stuff will be, it'll get hard enough in the coming months with our new units that are coming on the way soon after this one. So we'll start again. It'll just be some reasonably simple problems. In the next video or two, we'll see if we can throw together some word problems so that you can get some practice sort of extracting information from a paragraph rather than me just giving you an equation and asking you to solve for something. Because this algebra stuff does have a lot of real-world applications, and when you're sitting in front of just an equation with some variables and some letter x's and y's and whatever, it can be a little bit harder to see the connections to the real world. So we'll see if we can get some word problems coming decently soon-ish. But for now, this lesson will just be another one of those where we're working through just a handful of examples. Hopefully nothing too complicated. I know I said this before, but hopefully this one won't be a super long video, because it is just a few practice problems, and this is, for most of you, I think, stuff that we saw last year and ended up getting comfortable with last year. But we won't rush through it. We'll take our time. But that said, I'm going to sort of speed through the first one, which I am writing now, just because this is the same level of difficulty that we were dealing with before. And then we'll go through the remaining ones at maybe a faster pace than we initially were, but we will we'll pause whenever I want to highlight a specific point or two about a certain problem. So there are a couple of things that I'm going to point out for each of the problems after this one, but this one is fairly straightforward. So we'll start the same way we always do. We want to group all the terms that have excuse me, all the terms that have variables on one side and all the terms that don't have variables on the other side. So I've got this 5x here, and I've got this 3x being subtracted, so basically this negative 3x over here. So I can group those two together. We've got 5x minus 3x is going to be on the left side, but I don't want this 2 to be stuck here with it. So I'm going to throw it over on the other side of the equal sign. That 2 that we started with is still going to be there, and basically we're subtracting this 2 away from this side, so that means it's going to be subtracted on that side as well. Hopefully this isn't too confusing. We've spent a little bit of time going through practice problems that involve this sort of separating the terms with variables on one side and the terms with no variables on the other side. But so basically what we've done is we've taken this 5x, we've put it down here. We've taken this 3x, we've put it down here. This 2 hasn't moved. And this 2, we've subtracted it from the left side. So basically what we had is 5x minus 3x. We originally had this plus 2. But now what we've done is we've gone and subtracted that 2 from the left side, which means that from the right side, which used to have just a 2, we've now had to go and subtract 2 from that as well. So that's why we've got 2 minus 2 on the right side. Now on the left side, 5x minus 3x is going to leave us with 2x, right? If you start with 5 oranges and you subtract 3 oranges, you'll be left with 2 oranges. And on the right side, we've got 2 minus 2 is equal to 0. So now we've got a little bit of a strange situation where we've got something with x's on one side and 0 as opposed to some other number like 1 or 3 or 10 or whatever on the other side. So this 0 could create a little bit of a problem. It's not any more complicated to work with than the problems that we've been dealing with so far. But this is a place where people sometimes tend to get a little bit tripped up. So, so basically, we'll just proceed as we normally would. We don't want to know what 2x is equal to. We want to know what x is equal to. So we're going to divide this side by 2. But if we're dividing this side by 2, we also have to divide that side by 2, right? So then on the left side, this 2 on top and this 2 on the bottom will disappear, and we'll be left with just x on the left side. And 0 divided by 2 is still going to be 0. So then we figure out that our answer for this one must be that x is equal to 0. That's the only solution that's going to make this equation that we started with true. So in order to go and check that, maybe let's actually do that. Let's go and check that. We'll start with the original equation, which was this thing up here. Just get rid of all the stuff we drew over top of it. And we'll plug in x equals 0 and make sure that the left side equals the right side. So we know x equals 0 was our target solution. So let's go ahead and plug that in. So then up here, our first term ends up being 5 times 0. Then we've got plus 2. That's an addition sign, not a multiplication sign or a star or anything. So we've got 5 times 0 plus 2 minus 3 times 0. If you see brackets around one of the numbers but not the other one, that still means multiplication. So this is the same thing as this. Alright, so hopefully that's not too confusing. I'm not doing that as like a, oh, you need to know this because I'm getting lazy and want to complicate your life. It's just that for me, in the math that I do, sometimes I'll get a little bit lazy and I'll only write parentheses around one of the terms. So if that sort of trickles through into some of these, I apologize, but I'm not doing it to confuse you, and I'm doing my best not to do it out of laziness either. So we've got 5 times 0, so we've turned that x into a 0, plus 2 minus 3 times 0, we've turned that x into a 0, is equal to 2. Now over here, 5 times 0 is just 0, great, plus 2 minus 3 times 0 is 0, is equal to 2. Now obviously if you're adding and subtracting 0, that doesn't really matter, so that leaves us with 2 equals 2, and we can see without much trouble that that is indeed the right answer. So we can be confident that x equals 0 is the right answer for this one. Alrighty, next one. This one isn't set up to be much harder. It's just going to sort of remind you of a property that we talked about last year, but maybe we haven't talked about it too much, or at least not in too much detail yet this year, which is, actually maybe I'll write down the property first. So the property is one that hopefully you'll be familiar with, but it is called the distributive property. So I'm just going to write that up in this corner, and then we'll leave it there. Distributive property. So the way this works is, if you've got, let's say, b plus c being multiplied, do I need more space? No, I should be fine. Being multiplied by a. So we've got a times b plus c. A being multiplied by this entire thing over here. We can expand this out by taking this a and multiplying it with each term inside the bracket. So that is, we would do a times b. So a times b. That's not really well lined up, but forgive me. So we've got a times b and a times c. And since there's no minus sign in between, we'll just add those. We'll copy the sign from over here out to there. So we've got a times b plus a times c. This is the distributive property. So this is something we'll keep in mind in the next example. I'm going to squeeze the example up in here, or the question up in here, and then we'll work on solving it. So we've got 15 times x plus 3 is equal to 120. Alright, so here's the question right over here, this thing. So we haven't spent a whole lot of time talking about distributive property yet, and that's because before we were working with algebra, if you just had a number here, there was no point in doing the distributive property. You might as well just solve what's in the brackets first. Like if this was a 2, you might as well go and solve 2 plus 3 equals 5, and then multiply that by 15 to get your answer. And of course we wouldn't have had that 120 over there. We would have had 15 times like 2 plus 3 equals what? And so you'd have to solve for what's in the brackets, multiply that by 15, and you would get your answer, which in that case would have been 75. But for this one, we know the answer, and the thing with these brackets here is that we can't add 3 and x together. That's the difference between the problems we're doing now and the problems we were doing before, is that if these two things could just simply be added together, then great, no problem. We might as well just go ahead and solve them that way. But since we can't do that, we have to use the distributive property. So the way that's going to work is if I set it up the same way, just sort of down here, what we're going to end up with is A, in our sort of generalized form of the distributive property there, A is 15, B is going to be x, and C is going to be 3. So we've got 15 times x plus 3. So hopefully you can see that that's the same format as what we had up here. So then if I go ahead and I do that multiplication, it's going to be 15 times x first, so that'll be 15x. And then it'll be 15 times 3, and since there's a plus sign in the middle, there'll be a plus sign over there, and 15 times 3 is 45. Alright, so hopefully that makes sense. So that 45 in there, let me just make a note, has come from 15 times 3 is equal to 45. Alright, so now that means I can expand this out one line down, right? So we've got 15 times x, that's going to be 15x. And 15 times 3, that's 45. With a plus sign in the middle, we're not dealing with any negatives yet, equals 120. So now we're getting closer to the answer. Now it's set up like the problems that we've been doing so far. So now it's not that big of a deal. We've got one x over here that we need to solve, and we want all the things with variables on one side of the equal sign, and all the things without variables on the other side. So I'm going to take this 45 and subtract it. So I'm going to take this 45, and however you like to think about it, either we're subtracting 45 from both sides, or we're taking this 45, and as we throw it over the equal sign, we switch the sign. It was being added over here, so it'll be subtracted over there, or it was positive over here, it'll be negative over there. However you want to think about it. But what we'll ultimately get is that 15x is equal to 120 minus 45. Hopefully this is making sense, and hopefully I've explained how to move things over from one side to the other enough that this is making sense with some of the examples. And so now let's go ahead and calculate 120 minus 45. So I'll rewrite the 15x, we're not going to touch it, we're just going to solve that right side. So 120 minus 40 would be 80. So minus another 5 should be 75. Let's just double check and do 75 plus 45 and see if that gives us back our 120. 5 plus 5 is 10, 7, 8, 9, 10, 11, 12. Yeah, so we got our 120 back. So that means that is going to be 75 over here. But 75 is the same thing as x times 15. We don't want x times 15, we want just x. So we'll divide both sides here by 15. Or you can think of it as taking the 15 that's being multiplied over here and throwing it over to the other side of the equal sign and flipping the operation. It was being multiplied over here, so it'll be divided over there. Or you can think of it the way I've written it out right now, which is you just divide both sides by 15. So that 15 and that 15 will cancel. We'll be left with x on the left side, which is good. And on the right side, we get 75 divided by 15, which should be 5. Alright, hopefully nothing too complicated there either. Distributive property can take a little bit of practice, and as we progress into the next unit and the one after that, we'll see it pop up more and more often, and there are little sort of extra levels of complexity that we will see in our quadratics unit, but I think that's 2 units from now. You guys will still have the winter break before that, so our quadratics unit is still some time away, so I don't want to get too bogged down into the little details of the distributive property, but it will make a reappearance soon enough. But hopefully this is making sense, and this problem using the distributive property is making sense as well. That said, just to make sure it's making sense, I'm going to leave it as an exercise for you guys to take this x equals 5, plug it into the original equation, and see if it spits out the same answer that you would expect it to. Hopefully that sounds fair. And yeah, just see if plugging in a 5 over here will actually get you 120 on this side, or however you want to solve it, and see if you can get a 15 on both sides, or whatever. However you want to go ahead and solve it, just try and take that x equals 5 and solve it, and plug it into the original and solve that to see if it agrees with, or to see if both sides of the equation agree with each other. So, we're going to file away that information about the distributive property until another day. Our next 2 problems are not overly complicated, but there's a slightly a slight change in the way we're working on this problem now. There isn't a significant difference for the most part. It's just a couple of things I want to point out. But let's just jump right into it. So the first one is going to be x squared plus 3x squared minus 8 equals 8. Alright, so now we've got an added level of complexity in that instead of dealing with x's, we're dealing with an x squared in each of those terms. Now the thing with x squared is it behaves the same as x in the sense that you can add terms with an x squared to other terms with x squared. So we could add these 2 terms together to get x squared plus 3x squared is going to give us 4x squared. So you could treat this as, you could pretend this is, instead of calling it x, well, we can't call it x because it's clearly different, you could call this y, right? For example, this is, you don't have to do it this way, and if this isn't making sense, then ignore it. But you could replace the x squareds with y and just pretend that instead of dealing with something squared, you're just dealing with a different variable, which we can call y. So then we would have y plus 3y minus 8 is equal to 8. And then we can see that you can just add together those terms with y's, even though the y is actually representing an x squared. So you would get 4y minus 8 equals 8, right? So all I've done is I've renamed this variable from x squared to y, and then just worked on the problem with that. Or you could just leave it, you know, the way that we'd sort of started this, which if I erase that, or if I erase this and rewrite what we had over there, is it'll just be x squared plus 3x squared, which is going to be 4x squared minus 8 equals 8. Which you can see if we did it with y's will give us the same sort of setup. All we have is this x squared doing it one way, and this y doing it the other way. If this thing with the y works out well for you, feel free to solve the entire problem that way. Just remember that if the question has asked you to solve for x, and it's given you a whole bunch of x squareds, and you rename them all to y, getting a final answer of y equals something isn't enough. We need to turn that y back into the x squared and sort of deal with that. We'll see that a little bit later on, so if I'm just babbling and confusing you right now, don't worry about it. We'll come back to problems where we end up renaming some of the variables and then sort of changing it back and solving for those all over again. So for now, I'm going to get rid of this line down here with the 4 y's. We'll revisit this concept at a later date, hopefully not too long from now, but we'll see. So if we just take it from here, 4x squared minus 8 equals 8, we want all the things with variables on this side and all the things without variables on that side. That's a rule that we're going to break a little bit later, maybe not in this unit so much, but in our next unit and the one after that. That's a rule we're going to break, just a heads up. But for now, when we're just trying to solve for this one variable, that's what we want. We want to keep all the variables on one side and all the constants, all the numbers, on the other side. So if I just rewrite this, if I take that -8 and I throw it to the other side of the equal sign, it'll end up becoming a +8. Or you could think of it as adding 8 to both sides. So ultimately we get that 4x squared is equal to that 8 plus 8. Right? So that this first one is that 8 over there, and then the second one is the 8 that was originally -8, and we threw it over to the other side of the equal sign and it became +8. So if we go and we add those two together, we're going to get that 4x squared is equal to 16. But I don't want 4 times x squared, I want just x squared. So let's divide both sides by 4 to get rid of the number. So then this 4 and this 4 will cancel, so we'll be left with x squared is equal to, well, 16 divided by 4 is 4. So now we're very, very close to being done down here. So we had 4x squared is equal to 8 plus 8, that's 16. So we had 4x squared is equal to 16. We're dividing both sides by 4 so that we can get rid of all the numbers from the left side. But so that leaves us with 16 divided by 4 on the right side, which is going to give us an answer of 4. But we still have that pesky exponent of a 2 over here on the left side. So here we have to sort of we have to make use of the things from our last unit, which involved square roots, right? We want a number such that when it's squared, it equals 4. But if you take the square root of x squared, so let me see if I can find room for this. Yeah, I'll just throw it over here. All right, we're continuing this question over here. So we know x squared is equal to 4, but I don't want x squared, I want x. In order to get x, I'm going to have to take the square root of the left side, so that's going to be the square root of x squared is equal to the square root of 4. Alright, hopefully that's making sense. Now the square root of x squared is just going to be x. That's not a problem. Right? The square root of anything squared is the original base. Right? The cube root of something cubed is going to be the original base. So we've got x squared. When you take the square root of that, you're left with just x. Now over here, you would ordinarily think, and if you punched it into a calculator, it would give you this, is that the square root of 4 is 2. But remember that for square roots, there's a positive answer and a negative answer. So the answer could be positive 2, or x could equal negative 2. Alright, because if we had negative 2 and we squared it, negative 2, this is another sort of add-on to this question, negative 2 squared is the same thing as negative 2 times negative 2, negative 2 times negative 2, which is equal to positive 4. So that means it fits the bill for the square root of 4. So it could be negative 2, or it could be positive 2. So then we would express our final answer in a sort of condensed format. You could write it this way. You could write it as x equals positive 2 or x equals negative 2, or you could write it in a more condensed format, which looks a little bit like this, which is x equals, and then sort of put like a positive sign right on top of a negative sign, that's plus or minus 2. And you can write it that way as well. That's perfectly valid. So x is equal to positive 2 or negative 2. So the slight thing that's different with this problem is that there are 2 correct answers, and on a test or something, ideally, you would be expected to find both correct answers. Alright, so that's sort of the added level of complexity with problems like this one, is that you can get multiple answers, and we'll explore that more in later units as well. But yeah, I think that's the only thing I wanted to point out for this question, is that you can get a positive answer and a negative answer, so just keep that in mind when we're taking our square roots. Okay? Now the last problem we're going to do today, it's a very simple one. It's simpler than the ones we've been doing so far. But what if the number that you're taking the square root of doesn't give you a nice integer answer. So like the square root of 4, we got lucky. Our final answer was 2 or negative 2, which is great. But what about something like the square root of 5? It's not a nice, neat, and tidy number. Or the square root of 8, or the square root of 13, or something like that. They're not nice numbers when you take the square root of them. So let's do one last and final example for today, which is going to be x squared minus 1 equals 1. Alright? Looks deceptively simple. We don't have to deal with multiple terms that have variables. There's just the one term over here that has a variable in it, so that's x squared. And we just want to take this negative 1 and get rid of it. So we'll move it over to the other side here. So we'll be left with x squared is equal to 1 plus 1, right? We could think of it as adding 1 to both sides, or taking this negative 1, and when we check it over there, we switch the operation from subtraction to addition. But however you like to think about it, we'll end up getting that x squared is equal to 2. Now here's the problem. In order to get just x, I need to take the square root of both sides. So I'll write this down as an extra step. So the square root of x squared is going to equal the square root of 2. Now the problem is the square root of 2 is not a very nice number. It's like 1.414 something something something. So that's not very helpful, right? That's 1.414 something something. But here's the problem. It could be 1.414 something something, or it could be, that should be an equal sign there, or it could be negative 1.414 something something something, right? So it's the same rule that we were talking about with square roots before, that like the square root of 9 could be 3, or it could be negative 3. The square root of 16 could be 4, or it could be negative 4. Here, the square root of 2 is going to be some irrational number, some never-ending decimal, or the exact same number but with a negative sign in front of it. Now, we don't want to write out this weird sort of number, especially if it never ends, and then have to write it a second time with a minus sign, or even doing that, you could even write it as plus or minus of one of those, of that 1.414 blah 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 blah. But that would mean you have to somehow calculate the square root of 2. And while we have studied how to calculate square roots, this is sort of beyond the stuff that we were examining in that unit. Now, the left-hand side here isn't that hard to deal with, right? The square root of x squared is going to give us just x, no problems there. But over here, we're having a little bit of trouble, because the square root of 2 could be positive some complicated number, or negative the same complicated number. So the way you could write this is the most precise way that you can actually write this number is to just leave it as the square root of 2, but the one thing that you can add to it to make it even better for solving for x is because we're taking a square root, there's going to be two answers, a positive one and a negative one. So we'll just make sure everybody knows that and give ourselves a little reminder that there are two answers for x, which is the positive square root of 2 and the negative square root of 2. So what we've written down over here is the same thing as saying x is equal to the square root of 2, whatever that number is, or x is equal to negative square root of 2, which is a very similar idea. That's a negative sign not attached to the root sign, so something like that. Okay, hopefully that's not too confusing. So on a test, if you happen to find yourself with needing to calculate a square root of a number that's not a perfect square, so not like 1, 4, 9, 16, 25, 36, 49, those kinds of numbers, those numbers that when you take the square root you get a whole number. If you're not taking the square root of a number like that, the best way to write it down is to just sort of leave it as square root of whatever. And the only thing that you can do to improve on that when you're writing it as x equals something is because we've taken the square root and there's two answers, a positive one and a negative one, just throw in that plus minus sign right in front over there. Alright, hopefully that makes sense. This would be our final answer down here for this problem. And if you went ahead and plugged that in, you'd be able to see, let's go ahead and plug it in just to see what happens. So if I get rid of all of that stuff, so that means I'm plugging in the positive square root of 2 or the negative square root of 2 into our starting equation. So let me divide it into 2, and we'll plug in each of those, and then we'll call it a day. So we know our answer is positive root 2 or negative root 2. So if I plug in the positive square root of 2 over here, that means it's going to be the positive square root of 2 squared minus 1 equals 1. And on the other side, it'll be the negative root of 2 squared minus 1 equals 1. Now, when you square a number, the answer is always going to be positive. So the square root of 2 squared is going to be the square root of 2 times the square root of 2 minus 1 equals 1. Square root of 2 times square root of 2 is going to give us 2. Minus 1 equals 1. And 2 minus 1 equals 1. So we can confirm that on this side, on the left side, with this positive square root of 2, that the math checks out. So x can be the positive square root of 2, no problems. Now over here, it's going to be negative square root of 2 times the negative square root of 2 minus 1 equals 1. Now this is a negative times a negative, so our answer is going to be positive. And we know from over here that the square root of 2 times the square root of 2 is just going to be 2. Those negatives have disappeared. We keep that minus 1 equals 1. 2 minus 1 equals 1. And again, we can see that the math checks out. Alright, so hopefully there aren't any questions about those examples there. In the next day or two, I should be putting out a video involving some word problems, and then soon after that we'll get into stuff that's a little bit more complicated. Still need to get in touch with you guys about where exactly we're at, and if we're going to be missing lessons for the winter show or things like that, in which case I'll see if I need to modify my schedule of topics to make, but that's something that you guys don't have to worry about just yet. But if there are any significant changes to the plan, I will let you know in the not so distant future. So hopefully we're able to get anything that needs to be sorted out. And yeah, if you guys have any questions about any of the topics that we've covered recently, let me know. You guys have my contact information. Otherwise, I will see you in the next video. Have a good one.